The next topic is learning, which is related to the following question. Who populates the forwarding tables of Ethernet switches? The forwarding table of a link layer switch is initially empty. The switch fills the table based on the traffic it observes. For example, if the switch receives a packet with source MAC address 10 at link A, then it adds an entry to the forwarding table indicating that if in the future it receives a packet with destination MAC address 10, it should forward that packet through link A. Now, if the switch receives a packet with a destination MAC address for which no entry currently exists in its forwarding table, it broadcasts that packet to all the links. Now, it's not really all the links, it's a subset of the links in order to avoid loops, but we'll discuss that case in a couple of slides. So in our example here, switch S has received a packet with destination MAC address 10, and it does not have an entry in its forwarding table for that MAC address. So what does it do? It broadcasts the packet out all the links. Now, if switch S later receives a packet with source MAC address 20 and destination MAC address 10, first of all, it adds an entry in its forwarding table indicating that if in the future it receives a packet with destination MAC address 20, then it should follow that through output link B. It also checks what is the destination MAC address of this packet. It is 10. Do I have an entry for this in my forwarding table? Yes, I do. I should forward this packet through output link A. So, a link layer switch learns from traffic. So, when a packet with source MAC address X arrives at link Y, the switch adds a corresponding mapping in its forwarding table, so that it knows what to do if in the future another packet arrives that has destination MAC address X. Moreover, a switch broadcasts a packet out multiple links at the same time when it does not know which is the correct output link for it. In particular, when it receives a packet with an unknown destination MAC address for which it does not have an entry in its forwarding table. So all this process is called learning, through which a link layer switch fills its forwarding table. It serves a similar role as IP routing, but there are also differences. L2 learning relies on actual traffic, so the switches do not exchange explicit routing information. In contrast, IP routing relies on a routing protocol, so routers exchange explicit routing messages. Now, I said previously that when a switch receives a packet with an unknown destination MAC address for which the switch does not have an entry in its forwarding table, the switch broadcasts the packet. However, if all switches broadcast packets with unknown destination MAC addresses to all links, there may be forwarding loops. So look at this example. So let's say the first switch that receives the packet does not know anything about destination MAC address 20, so it broadcasts the packet. The second switch does the same, it broadcasts. The third switch does the same, it broadcasts. So the same thing continues and the packet keeps circulating inside the network. So naive broadcasting can lead to forwarding loops. So the second question of the lecture for you is, what could be done in order to avoid such forwarding loops? Think about it and we will discuss it on Friday.